Efficiency. In any real-world device, electrical device often, but really any sort of machine, what we're trying to do is we're trying to convert energy from one form to another form. And what that means then is that some of the during the conversion, almost inevitably, some of the energy will get converted into the form we want, but some will be lost to some other forms that we would consider to be wasteful. So let's take a light bulb as our typical example here. Here's our light bulb. A light bulb has a little filament in it, and when the electrical energy, when attached to a battery, so the battery attaches here, and the electrons try to flow through that tiny filament, the light bulb heats up, and then as a result, it produces light. This visible light is very useful because it lets us see in the dark. But the visible light is only created when this filament gets hot enough. And so what that means is that this electrical energy is being converted into two things. It's being converted into light, and and heat. The light energy was the energy we want. The heat energy is the wasteful energy. The efficiency of this device is defined as the ratio of the useful energy to the unuseful energy, or the percentage of energy that gets converted to the type of energy that you're trying to create. So the efficiency is the ratio of the useful energy in comparison to how much input energy was required. In the case of our light bulbs, the efficiency would be the amount of light energy produced in comparison to the amount of electrical energy that was input. Since this amount is always less than 1, we often express it as a percent. So we might say that a light bulb, for example, is something like 10% efficient. What that would mean is for every 100 joules of electrical energy that went in, we got 10 joules of light energy. So 0.1 is the ratio, the efficiency, but expressed as a percent, that's 10%. Efficiency has become more and more important in our world as we try to continue to have all the conveniences and all of the things that we have machines do for us, but we finding sources of energy, inputs of energy, more and more difficult and more taxing on our environment. What that means then is that it has become very useful to create more efficient devices. For example, devices that can output the same amount of energy, but while using less input energy. An example of this might be something like an LED light bulb. Because an LED light bulb does not use the filament and incandescent method, it uses a different method to convert electrical energy into light energy. It never needs to heat up to the same temperature that an incandescent light bulb would need to heat up to. What that means is that an LED light bulb does not produce anywhere near as much heat. And so more of the electrical energy goes straight into becoming light energy. Now, in a room, let's say that used to have a 100-watt incandescent light bulb in it, there's no reason that you still need or that you need more light just because you're using an LED bulb. So let's just play around with the numbers that we've said. Let's say an LED light bulb, because it doesn't produce the heat, is actually 50% efficient in comparison to 10%. What that means then is if we were putting 100 watts in and only getting 10 watts of light, 100 watt is your input electricity, and 10 watts is your light out, and this is for an incandescent light bulb. Then if we switch to an LED bulb, where we've said, by the way, the incandescent has a 10% efficiency, if we switch to the LED bulb, we still only need the 10 watts of light output. What that means then is if the LED is going to be 50% efficient, then we say that efficiency is equal to the useful divided by the input. So we say our 50% efficient bulb only needs to produce 10 watts of light energy. Then what we can figure out from this is that the input energy would only need to be 20 watts. So our old incandescent light bulb required 100 watts of input energy to produce the 10 watts because it is only 10% efficient. Alternatively, our LED bulb, which is 50% efficient, can produce those 10 watts while only inputting 20 watts. What that means then is that we've used 80 watts less of electricity lighting that room. Obviously, again, as our society tries to find ways to reduce the amount of energy that we're using for environmental and other reasons, then devices that are more efficient are one of the main ways that we're trying to do that.